Thank you. Can you all hear me just fine? We good? All right. Well, good afternoon again, everyone. And as was stated, my name is Shawn Conley. I'm the State Soybean Small Grain Specialist at the University of Wisconsin-Madison. I run a very open and informal program, so feel free to ask me any questions as we go through. I would much rather have this be an open discussion than me boring y'all with 50 minutes of slides that you don't care about, okay? So feel free to ask me any questions related to soybean, small grains, anything around that area. If you ask me anything on corn, I'll just say my preferred way of controlling corn is select max, but everyone else can figure out how they want to control it. So as I kind of go through here, I always want to make sure, first of all, I thank all my co-speakers, if you will. These are all my graduate students and technicians and partners in this. I am very fortunate to have very good grad students, postdocs, technicians, and collaborating PIs. It makes my life really easy to be able to run a pretty big program and not really have to worry about what's going on. So I always want to thank them. And most importantly, I always want to make sure I thank the Wisconsin Soybean Marketing Board. The Wisconsin Soybean Marketing Board roughly funds 80% of my program through checkoff dollars. So if it wasn't for the direction and the work with the Soybean program, Marketing Board, it helps direct and make sure that the research that I'm doing is applicable at the farm scale, behind the farm gate. They really kind of help not only bring ideas forward, but they also help make sure that I stay on track on things before I kind of get a little loopy and go over in left field and try and do some things. So again, I want to make sure I thank them, and frankly, through some of my United Soybean Board funding, I'd like to thank the farmers here as well that you pay checkoff dollars in, and it's funded some of this research you'll be seeing today. So I just want to make sure I give credit where credit is due. Now, usually when I go into a newer audience, it's been like 3 or 4 years since the last time I was here, I kind of want to give everyone kind of a quick and dirty about the program that we run here at Wisconsin and the work that we do. So under part of my umbrella, if you will, would be the soybean and winter wheat variety testing programs. This right here is a map of all of our soybean variety testing programs, and that side of the program is ran by Adam Roth. Okay, so he manages corn, the soybean and wheat variety testing programs. Now, if you look from the north, I usually call this the tree belt right here. Okay. Where you basically get north of here, all you have are pine trees and timber wolves and a few black bears, okay? That's usually where we're at a 0.5 maturity group bean, all right? From there, we go all the way down to the Wisconsin-Illinois border. We will test maturity group beans up to a 2.9. We have farmers growing seed production fields as well as going across the border, because seeds reps will not sell them more than a 3.0, getting early 3s and bringing them into Wisconsin. So that kind of gives you a range of the maturity group that we see across the state. Now within each location here, these are variety trial locations, and it's really hard for you all to see, but I'll pick out the East Troy site because last year it was my highest yielding site, and I always like to show that site. Our lowest yielding variety at that location last year ran 70 bushels per acre. Our highest ran 100 bushels per acre, and our trial average was 87 bushels per acre. So that gives you a sense of the maturity group and yield range we see north to south. Obviously, we get up to Spooner, we go 44 to 74 with an average of 56. So we see a lot of variability north to south as well as east to west across the state of Wisconsin. All right. Now, the good thing about running these variety testing sites is it gives me access to all of those locations. And only about a third of them are on research stations. The other 2/3 are actually on farm, working with farm managers across the state, which really makes my life easy because they do an excellent job of weed control, fertility levels are high. I don't really have to worry about much, just showing up, planting, killing the weeds, and harvesting. So it makes my life really easy, and I always want to thank those farmers, and again, that gives me some high-yielding sites to go into. But again, what that allows us to do is agronomic production work at all of these locations. We'll run seed treatment, seeding rates, trials, row spacing trials, fungicide trials across the state to help us really kind of pinpoint and tune our recommendations based on the environmental characteristics that we see. Okay? Now on the flip side, I always want to point out this has been not the Wisconsin, but U.S. soybean production in red here. This is harvested acres. And in the green line here is production value from 1996 all the way up to 2018. As many of you are probably familiar with the fact that in 2018 it was the first year that soybean acres surpassed corn acres on a national basis for having the most acres or acreage in 2018. Now, I don't expect that trend to continue. I've been basically inundated with radio and magazine questions from reporters asking me if I looked in a crystal ball, what would I think is going to happen in 2019? And I said, well, it depends on what our president does. Okay? It's all going to be predicated on the tariffs. If this tariff is not resolved, I would expect at least a 10% reduction in soybean acres nationally. All right? That will be regionally based. If you go into North Dakota, South Dakota, where the primary market is the Pacific Northwest, where a lot of those beans are sitting in piles or in elevators and haven't moved, I expect to see a lot more acreage shift in those areas versus on the Mississippi or maybe over where you all are here, where you have access to different markets. So again, I think it'll be regionally based, but if nothing happens, okay, I would say I'm guessing at least a 10% national reduction in soybean acres. Now, with that being said, there's a lot of caveats out there, okay? Lots of caveats out there. One, obviously the Farm Bill. The next is some of the, I don't really want to call it a bailout program, but a bailout program that we have in the short term. And lastly, and I don't know how it is here in the Mid-Atlantic, but in Wisconsin, in the Midwest, if you don't have the capital to do what you want to do, who do you got to go talk to? The banks, the lenders. And the lenders are going to say there's less risk for us as a lender for you to plant which crop? Soybeans. So that's going to be a driving factor. I would think maybe we won't get a 10%, and the main reason for that is the lenders not giving out crop loans for growing corn. Okay? So again, that is another thing we have to deal with. So again, that's my prognostication. I'm hoping, because there's two different camps. One camp said this will be resolved shortly after the elections, no matter what happens. And the other one, this is going to be a long haul. I'm hoping for not the latter. I'm hoping this is resolved by the time we stick beans in next year, and we can all move on from there. But anyway, that's kind of what I foresee going forward. Now, one of the, the cool things I think that given the fact that I get to run the variety testing program, is that I get to monitor traits as they come into marketplace. Since companies normally enter the best, highest yielding varieties into my variety testing trial, I can basically look at overall trends and traits and how they perform as they move through, as they move into the industry. For example, when Roundup Ready 1 beans first came in the marketplace, we had conventional beans there. We could measure that Roundup Ready 1 beans had a yield hit for 5 years. Okay? We could monitor that. When Roundup Ready to Yield came into the marketplace, at least in the maturity groups that we work in, 2s and basically 3s and less, Roundup Ready to Yields came in and we're knocking the socks off of Roundup Ready 1s. Now, with the Extend beans, okay, this is the 3rd year I've had them in our variety testing program, and frankly, for the first 2 years, they have been running on average 2 bushels less than Roundup Ready to Yields. The first year was basically just probably where they were in terms of the pipeline and how quickly they came to the marketplace. Last year, most of the Roundup Ready, the Extend beans came with a genetic background that's pretty susceptible to white mold. Okay, so that kind of pulled the top end off of many of the varieties there. This year, however, we pull it through, and we see statewide the Extend varieties are outperforming the Roundup Ready to Yields. okay? If we look statewide, we're a little over half a bushel greater, and that's statistical if anyone cares, greater with the Extend beans over the Roundup Ready yields. And this is averaging over 255 varieties. So it gives you a sense of how we can kind of pull out some of those differences. If we go from our southern region all the way up to our central and north central, so this would roughly be a 1.5 bean all the way up to a 3.0, we're running positive 1.3 to 1.7 bushel greater yield on average across those varieties. However, when we get into the northern varieties, which are a 1.0 or less, we still see in that case the Roundup Ready yields outperforming the Extends. And that makes sense. Where do most of the soybean varieties go? What maturity group beans? 2s, what else? 3s, and what else? 4s. So where's the primary breeding effort going to go? 2s, 3s, and 4s first. And then where do they go? Less than 1s, over 4s. At least that's what we traditionally see in our environment, and maybe it's a little different out here, but that's kind of what we see. So again, this kind of gives us a trend of knowing where we are and how we perform. Because last year, we did not have the water hemp issues that we see in the Mid-South or the I-states. Well, water hemp blew up this last year, so we're going to go from probably having less than 20% of our varieties in Wisconsin to be Extend beans to probably 60%. And from very few commercial applicators applying Extended Max or Ingenia or whatever product is in the marketplace to probably most of them applying it. So we're going to see a big transition year this year. But that's kind of what we're seeing. I don't know if it's similar or different out here in the Mid-Atlantic, but again, that's kind of our perception of what we're seeing in the Wisconsin and the Midwest. Any questions on this before I, yes sir?
So it's not the technology that's making the increase, it's the breeding of new varieties.
Right. The question is not the technology. And to this point, there are no yield enhancing traits in soybean. They're all protective traits. Okay? Be it, in South America, they have the lepidopiran trait, which isn't in the U.S. because we don't necessarily, well, you all might need it. But the big soybean growing areas don't really need it. But the rest of them are all herbicide traits. So they basically protect yield and they don't enhance yield. Good question. Any other questions on this topic before we get into what I advertised that I was actually going to talk about today? All right. Now, so I'm not going to tell you, the title of my talk are Does Crop Rotation Still Matter? And if you all want to leave early, if you sign your CCA sign-up sheets, the answer is yes. Any questions? Okay. Well, let's dig into this a little bit more and kind of figure out where these nuances kind of fall into place. And again, we've all known this ever since humanity started cultivating crops. You can go back and look, and they've done crop rotations because they figured out if I switch crops, next year this crop goes in there, guess what? I get a higher yield. Okay? The biggest challenge for us is to be able to kind of characterize where that yield comes from. And we know a lot of it's driven by increased soil fertility, soil physical properties, different weed control strategies or technologies, and improved insect and disease control. So we can clean a lot of that up, okay, with different technologies and traits. Okay. However, we still see a yield difference, and that's being characterized by this magical rotational effect that we really don't have a handle on yet. Okay. I think some of the technologies and tools, we'll talk a little bit about those a little bit later, can help us dig into that profile a little bit more. But let's kind of look at the macro picture of what we're really seeing. So I've had the advantage of having some of my predecessors that had more foresight than I have into establishing many of these cropping system trials long before I got to UW-Madison. I'm going to talk through two of the many systems that we have, ones that would most readily translate to the Mid-Atlantic region. And the first one here is this corn, soybean, wheat rotation study. This was established back in 2002, all right? And again, there's a bunch of splits and stuff, and we'll get into that a little bit later, that we were able to overlay different management strategies within these rotations to see if we can reduce some of the yield loss associated with these rotations. And again, we'll talk about that a little bit more, but let's kind of dig into these main plot effects. So in this continuous soy, Some of these plots have had continuous soy since 2002, continuous corn since 2002, and remember this is 2018, so that gives us 16 years of running data we're up to at this point. We have ones that are in annual corn-soybean rotation, which means both phases are out in the field every single year, both corn and soy in that corn-soybean rotation. We have continuous wheat, and then we have these different management systems. We have the corn, soy, wheat rotation, okay? We have the corn, wheat, soy rotation, and then we have more of a dairy type of a rotation, which is the corn silage. Obviously, we remove all that biomass off with the corn silage, wheat for grain, and then we bale all the straw off, and then soybean. So we have kind of the main cropping systems we have in the state of Wisconsin, for that matter, across the upper Midwest. All right? Now, you're going to see a lot of figures that look like this. I'm going to walk you through the first one so you kind of have a feeling for the figure layout, and then we'll go ahead and go through them a little quicker. And again, if anyone has any questions as we go through, feel free to fire away, okay? I'd much rather, again, have a little bit of dialogue and interaction here. So, here in these gold, this is corn yield, soybean yield, and wheat yield, okay? These are the systems. So CS would be corn, soybeans rotation. This would be corn, soybean, wheat rotation. CWS is corn, wheat, soy. And the CC would be continuous corn, all right? Now, if we look underneath, we are comparing all rotational systems against the continuous system. Okay, that's kind of, I don't want to say it's our benchmark, but we're looking at yield increases above what that continuous system would be. So this is continuous corn. Here, the CWS would be 2% greater yield. The CSW is 11% greater yield. And the corn soybean is 3% greater yield. So it gives us a sense that in this rotational system, if you're just looking at corn, what is the highest yielding rotational system? It is what? Corn, soy, wheat. Okay, so we've got the corn figured out. Now let's look at the soybean. Okay, in the soybean rotational system, what is the highest yielding rotational sequence? Corn, soy, wheat. And in the wheat, what is the highest rotational system? So what should we be doing? Corn, soy, wheat. That is what we typically see in the Midwest as the highest yielding system. What's driven us away from that system? The fact that wheat prices stink. Okay? We basically have lost roughly 500,000 acres of small grains in the state of Wisconsin since I started in 2007. So trust me, that does not go on my annual activity report for an accomplishment. Okay? On the flip side, what crop do you think we've gained acres in? Soybeans. We've roughly almost gained 1 million acres of soybeans in that same time frame. Okay? So that's what's driven us apart. The one thing we do need in Wisconsin, however, is roughly 400,000 acres of some kind of small grain. Why do you think we need that? For what purpose? To haul cow manure. That's frankly the only reason, well, 2 reasons, and then we bale off the straw and it goes into TMRs because they want basically the microbes to work on what? The wheat straw, because the rations are too hot because the protein content is so high in the alfalfa, corn silage, and whatnot. The only reasons we still have wheat in Wisconsin. Yes, sir?
You have double crop beans on that wheat out there?
We're getting more double crop beans, not on this system here,
I noticed, okay.
because, so to be frank, we, in our bottom 3 tiers of counties, in the last 5 years, if our wheat comes off by July 10th, growers can plant double crop beans because it's all treated seed. They get the treated seed in July for pennies on the dollar because otherwise it goes where? Landfill. So seed company is willing to get rid of it for a cheap price, and if they can get 10 bushels on double crop beans, they make money. So we see a lot of growers, and frankly, if it doesn't, it's a cover crop that sits out there and it's green manure, and that's what we do. So we are seeing more and more of that, and that's frankly whatever you want to call it. If you don't believe in climate change, fine. I call it weather variability. That keeps me out of the political crosshairs, okay? And what we really see is that it's growers are planting beans by April 15th. Wheat's coming off 2 weeks earlier. And we were getting a week on the back end. Growers get 10 bushel soybeans. It's just money. But good question. All right, next. Now, some of the highlights of some of the system experiments we can do, because again, we've been doing this for roughly 16 years. We can overlap different trials and treatments in here. And lo and behold, this is nothing that should be shocking to anybody here. By the time when we add wheat into that system, we get more fusarium problems. Fusarium head scab on winter wheat. There's certain parts of the state of Wisconsin, farmers, it's not the wheat price that dings them, it's the dockage on scab that docks them. So basically, if you go to southwest Wisconsin, where they can raise 250 bushel corn on 4 foot of loess soil, okay? They plant wheat in there, guess what happens? Down of 15, 18, 20%, can't sell it. So we've lost it in that area. So again, surprise, surprise there. Next, variety selection always trumps fungicide decisions. Now all of our work on these, okay, especially in a year like this where growers are going to have a challenging time with penciling out all of the inputs that they want to put in their fields to maintain yield, okay, I'm really encouraging farmers to spend a lot more time with the variety selection part of that. If you know what problems you have and there are resistant traits either on the corn side or winter wheat side, generally we see the profit and economics outweigh a winter wheat variety that may not yield as high but doesn't get scab, okay? There's some trade-offs we can look at there in terms of that. So variety selection always trumps fungicide decisions, all right? Next. So when we had $8 corn, $16 soybeans, or whatever the prices were, we were hearing a lot of coffee talk shop chatter, if you will, that the best way to grow our crop yields, doesn't care if it's soybean, corn, wheat, the rotational systems, is to push it hard and keep pushing it on every subsequent crop. All right? What I mean by that, and as a university person, I don't know if you would believe this or not, or shock you that industry does not always agree with what I have to say, okay? Frankly, it's usually the opposite, all right? But one of the things we were able to do is we had a trial where we were pushing, in this corn, soybean, wheat rotation, we were pushing hard and heavy with inputs. Lots of N, lots of P and K, lots of fungicides, okay? And that not just doing it 1 year and measuring yield, trying to build up the system. So we had 3 years of high input systems across soybean, corn, soybean, and wheat, all right? And after 3 years, what we basically did is we just pulled everything out, planted it like normally under BMP practice, and measured what type of a yield enhancement we got. And guess what we saw? After 3 years of pushing it, you had the 4th year of just managing it, you know, as normal. Guess what happened? Where did all the yields come? Back down. So basically what this told us is that at least with 3 years of pushing a crop, you're not building up anything, either nitrogen or fungicide, you're not building anything up in that system. In fact, when we're really pushing nitrogen heavy, guess what that did to our wheat yields? Boom! Okay, lodging, more fusarium head scab, lots of problems. You go into Minnesota, they're running into some of these issues now. You all don't have IDC out here, do you? Basically iron chlorosis. Minnesota, South Dakota, North Dakota, IDC is a big problem. A lot of that is being kind of shown with a lot of residual nitrogen in the background profile from the corn crop, not taking it all up. You plant the soybeans in there next year, they fire up with IDC because of the residual nitrogen, all right? So again, there's some things to continue to look at, but our data really doesn't tell us anything about this buildup of rotation. Any questions on this type of a system? Okay, nice. Now, the typical system that we have in the state of Wisconsin, and frankly the Midwest, is corn, soybean rotational system. We did this trial was enacted and started in 1983. I would have been 10 years old, so that means that trial's been 35 years in continuous or rotational systems, just so you kind of have a background of how long this has been in play. All right? So, however, rotational systems, this is a little bit different. So we've had continuous corn from 1983, continuous soybean from, I got those backgrounds, but you can read better than I could see, okay? Corn, soybean rotation, since 83. And then we have this unique rotational sequence that we have, where we basically have 5 years of a continuous crop, and then we flop it out and do 5 years of the next continuous crop. And the reason we do that is we're trying to see where in this sequence you move from being a rotated crop to when that plant looks like it would act in a continuous cropping system. Does that make sense? So we're really trying to see how many years in these rotational sequences do we basically hit the floor and are similar to that if you just did a continuous cropping system. Everyone clear on what we're doing here? Okay, excellent. So we're going to walk you through this. There'll be about 4 or 5 slides here. The first thing we're going to talk about is a rotational effect, because there is a rotation by tillage effect, but let's look at this main effect first. So the first one is looking at tillage. Okay, on average, over all these rotational sequences, in corn, the conventional tillage has a 5% greater yield than no-till. Okay? Here's our check, if you will, continuous corn. All right? Now, what we see here is in basically corn soybean rotation, we have 16% greater yield than we saw in a continuous corn. The first year of corn, coming out of 5 years of continuous soybean, we're basically very similar to that, what the corn yield would have been. Statistically, it's different. Biologically, probably not a big difference of that 2% of first year corn. Then we get into second year corn, and then by the time we get third year corn, we're basically at the same yield level as what? 35 years of continuous corn. So that tells you how quickly we get into that cycle. So by the time you plant corn 3 years in a row, boom, you're basically the same level as 35 years of continuous corn. Okay, does everyone understand that slide? Next, on the soybean side, we basically, here's the difference again between conventional till and no-till. We see basically a 2% yield difference, about a bushel greater with conventional versus no-till. There's a little background there, I'll fill it in a minute. Here's our continuous soybean levels, 49 bushels per acre. Soybean in a corn soy system, 15% greater. First year of soybean, okay, after 5 years of continuous corn, we're 24% higher yields. How long does it take before we get into basically the same levels of continuous soy? That third year. So similarly, I don't exactly have this treatment in here, but I can kind of pull this out, is when a farmer comes in and says, I'm in a corn soybean rotation, my banker told me he's only going to lend me money for soybean next year. Or I'm only going to plant soybean next year because I can't afford to cash flow that crop. What's my yield penalty going to be? So if you just look here, second year soybean is very similar in yield to the corn soybean rotation. Second year soybean, what yield hit are you going to take? Roughly an 8% yield hit. So when you run your math or you talk to your banker, say, this is what my yield level is going to be. I'm going to lose 8%. Okay? How am I going to cash flow that? So again, it just gives you a little bit more information and ammunition when you talk to your banker, or you all have spreadsheets. You're all working, everyone's got their spreadsheets. Make sure you calculate what your yield basis is for that second and third year cropping system that's accurate. Does that make sense to everybody? Okay. Next, let's look at this tillage interaction. Okay. In a continuous corn system, what should you do? Till. Okay. In a corn soybean rotation, what should you do? Whatever you want to do. Okay? Because the yield is exactly the same. The corn soybean rotation system. Where do you really have the big drop off at? In what year? Second year corn. Going to second year corn, you're going to need some tillage. Basically what we see from this data. All right? Now, again, you can run your own numbers to figure out what's that tillage operation cost versus my yield loss. There's some things you can all do with your own cost of production. You can sort that out in terms of the economics driving it. But this data basically tells us you got a till in second year corn. Okay? So the soybean side. When do you really need a till in soybeans? Continuous soybean system. Okay? Beyond that, we really don't see a difference between no-till and conventional till over this intended time frame. Where did we see this flip? 1996 was the year that no-till soybeans started averaging the same or out-yielding conventional till. What technology was introduced in 1996? Roundup Ready beans. What could we kill in no-till systems with glyphosate then? Everything. What do we kill now? Nothing. Okay. So this gives you a sense, okay, of where there's these interactions and there's some nuances here, but it kind of gives us a sense of why we see this break in this change. And frankly, on a larger scale, we've seen farmers in Wisconsin the last 5 years start noticing this gap between conventional and no-till beans start widening, and we'll talk a little bit more of that in a minute. All right, who's my timekeeper? What time is it?
It is 2:30.
I got 20 minutes?
20 minutes.
Perfect. All right, so I got 3 hours of material in 20 minutes. Okay, I'll keep this part brief because it's a little bit more nebulous, all right? So we've kind of talked about the physical factors of rotations and what we can measure via yield, but one of the interesting things that we've been able to kind of figure out now is this whole issue about what's going on below the soil ground, okay? So how many of my colleagues or people here are in academia, okay? Okay, for those of you in academia, what are the 2 words it's mandatory you have to put in a grant proposal to get funded today? Soil health and microbiome, okay? Those are 2 words, okay? So now we're going to kind of dig into that a little bit, all right? And basically what we're trying to do is just like the Bionic Man. How many remember the Bionic Man? Okay? We have the technology, all right? So now the technology is relatively cheap. I say relatively, okay? And relatively simple that we can start digging into this microbiome effect, all right? And we've known this for a long time, okay? That we have different plant species out there. They have different phenotypes. They have different root phenotypes. They have different root exudates. And those phenotypes and I said it right the first time. Exudates, close enough, okay, for an agronomist, okay, basically dictate what microbes, fungi are in that microbiome, right? Okay, we kind of know that. Now, what we're able to do is based on some of these rotational sequences and the fact that cover crops are a boom right now, and there's a lot of claims suggesting that adding a cover crop increases the diversity of the microbiome, which has a benefit on crop health or soil health, that we really want to go through and figure out, is this true? Okay? So that's kind of the work we're kind of progressing into. All right? So these are some of my research objectives. I'm not going to bore you with that stuff. That's Marion Lund. She's the scientist. So if anyone's looking for a good PhD student, they're working the microbiome, she'll be done in April. Just saying, she's really good. Really smart. You all don't care about this, okay? For the 3 academics in here, that's how we coded stuff, okay? Any questions? Read the paper, all right? Now, one of the things we were looking at here is, first of all, how do you characterize and classify this whole microbiome? Because there's a lot of stuff, okay? It's all sorts of stuff. And how is it functioning? And how does it play a role? And one of the simpler ways you can do is what they call this bacterial beta diversity, okay? In short, what this tells us is that we calculate the number of species that are not the same. How do we do that? pull a bunch of soil samples, you extract all the DNA, you throw it into a machine, a black box is what I like to call it. Stuff spits out and says, this is what's here, okay? I'm being recorded now, so I shouldn't say everything I think about that, but if you would have been here the last session, you would have got more detail on what I think about some of this stuff. But anyway, as I'm talking about it, isn't that ironic? That's what we as academics do. Now, one of the things we're able to do is characterize this, and what we can see here, here's a continuous soy system, continuous corn system, and here this corn-soybean rotation, obviously you have a lot of overlap, right? Which tells us they share a lot of that community of diversity, and why is that? Because every other year, what's in there? Corn or soybean, back and forth. Okay, so you're kind of not losing anything based on that rotational system. Now, if we look here, we can kind of track back of here's continuous corn, here's first year of soybean after 5 years of corn, second, third, fourth, fifth. So it kind of gives us an idea of how this diversity is changing over time and how quickly it changes. Similar one on the corn side, okay? But again, what this kind of gives us a better picture of how quickly can we change that diversity within that soil microbiome and how resilient is it. Does that make sense to everybody? Okay, perfect. These are OTUs. Not going to bore you with that. Okay, next slide. Beta diversity related yield. Not going to bore you with that. Next slide. One of the things of interesting though is this whole idea is, okay, so we could tell you what's there in a relative manner. You know, we can classify it by what species are there or how genus is there. We can kind of put in these different lumps. The question is, can we figure out what it means? Okay, so they have some of these EcoPlates. Okay, we're looking at biological function. All right, so basically what this tells us is we have these, this is a BIOLOG EcoPlate, we have these different carbon compounds out there. We extract the critters, if you will, from the soil. We add them in here and we see what they eat. Frankly, this is a carbon source. What are they eating? Is the simple way of characterizing this. And then we could basically measure the reflectance, because the brighter it is, the more they what? Hey, pretty simple of classifying this, okay? Again, it's getting at this idea of function. Because ultimately, people always ask me, who funded this research? And I said, the Wisconsin Soybean Marketing Board. And they're like, why would they fund this kind of basic stuff? And why do you think a grower group would fund something like this? Any ideas? It was not my smiling face, I can guarantee you. The reason behind that is if we can classify what is driving function, and we can basically characterize it and then add it back into the system, can we basically do something and influence this rotational effect? That's kind of the long-term role, as many of these grower groups are looking at. What can we do as we get tighter rotations and longer years of soybean into these systems? So that's kind of the background of what we're trying to do. Because how many of you are farmers? How many of you are crop consultants? How many of you get asked, should I add this biological into the system this year? Everybody does. We throw biologicals at it because why? It is a sexy thing to do. You think we know what the hell is going on? Oh, you can spot, delete the hell. Okay. I guess I said it twice. Delete it twice. Okay, so the point here is we're really trying to classify and be able to figure out which ones are actually providing function and value to a farmer. Does that make sense? Good. Okay. Now, in short, we did all this work. I should have taken this out. Blah, blah, blah. This is what took Marion roughly 1 year of her life is on this slide, if anyone has any interest. Okay. So these, how many of you know how to read BIOLOG plates? You know what this tells us here? Nothing. Okay? That's what we learned after all of this work. Okay? Nothing. But there's reasons behind that. Because a very small percentage of the microbes and fungi that are in a soil sample can you physically get out and wash through this process. So we're looking at roughly 5% of what's going on there, okay? So that's kind of gives us an idea that, well, of that 5%, they don't really mean nothing to the system, or we can't explain it, all right? Next, God, we really didn't learn anything there. Now, I'll talk about this slide, because this is kind of a cool slide. Now, how many of you have ever heard of a term called a fecal transplant? Okay. One of the things we're wondering, does anyone want to explain what a fecal transplant is? It's exactly what you think it is. Okay. So if you want more detail, I'll tell you later. Okay. So what we're really trying to do is, can we basically do a soil microbiome transplant? And what we did is we took a volume of soil and we added 10% of these different rotational sequences into that soil. For example, we got a volume of continuous corn soil. What we did is we threw in 10% of continuous soybean soil into that. We threw 10% of a corn soybean rotation soil into that. What we're really trying to do is, can we, even though we may not know yet what's happening biologically, can we basically influence that microbiome with these transplants? And in short, the answer, at least in a greenhouse setting, is yes. We can influence that. Okay, and we measured this here with corn leaf surface, corn root weight. Again, this is a greenhouse. I'm not saying this is going to immediately translate to the field, but it lets us know that we can do some of this transplanting. Okay, so it gives us an idea of what's in there can be moved. Does that make sense to everybody? So this allows us to keep digging, and as technology gets cheaper and we learn which areas to focus on, we can hopefully streamline this. All right, now flip gears. Because I got, what, 10 minutes, 5 minutes?
6 minutes.
6 minutes, precise. Okay. So one of the things so in Wisconsin, okay, we'll go back to this tillage thing. I mentioned earlier that farmers are really thinking at the farm scale that the conventional till soybeans are starting to outperform no-till, okay? Because our recommendations, state recommendations are no-till 15s. If anyone's starting with beans, we're saying no-till 15s, okay? Drop 140,000 seeds per acre, no-till 15s. Call me in the fall when you want to know corn recommendations. That's basically what we say. All right? Now, what we're really seeing here, though, is some of these farmers questioning that stability is holding up. So there's a farmer. His name is Mike Cerny. He's a member of the Wisconsin Soybean Marketing Board, a member of the North Central Soybean Research Promotion Board. So he's a very active, educated grower. For the last 5 years, he's been telling me, he's like, Conley, because he doesn't call me Dr. Conley, obviously. He goes, Conley, there's something going on with this strip till. And I'm like, sure, Mike, I believe you. Okay? No-till 15s are where it's at. The next fall, there's really something going on here. You got to look at this. Year 3, he calls me up and says, beep, beep, beep. Conley, get your beep down here and look at these beans. I said, yes, sir. Okay. So we walked down there and we started looking at these, and we could pick out these phenotypical differences between soybean rows. So on these, this is a 30-inch row strip plot. And he's always been on 15. So he strips 30s and plants 15s. He'll center, obviously, one on the strip till. And we notice these phenological differences of basically anywhere from 1 to 3 growth stages different. So we're like, okay, we notice this difference. You can physically go out there and look at them and see the potting is different on those plants. So what do we do in academia? We do minute, tedious work, okay? So my technician here went down and harvested these long strips, 1 row at a time, okay? Who here would like to be my technician? He is not smiling there. I should put a smiley face over his face. He is not smiling. However, we get into these individual rows, you know, there's a lot of variability out here, but the one thing that really popped out, that if we average it, you know, 1 row at a time on a per acre basis, that 1 row in the strip on 30s averaged 75 bushels per acre. Between the strip, which is effectively no-till, okay, 28 bushels per acre. Okay? So the point he wants to get at, to me, is twofold. Number one, I need to buy a new planter. Okay? Number two, okay, I don't want to buy more row units than I need. As you all know, if you work with farmers, each one of those row units is X amount of dollars. Okay? And if you can cut that in half and blow your planter up twice as big, what does that give you? A lot more productivity. He goes, I want to do that, but I do not want to lose yield. So the question is, can he move over to a strip till system? So, I know I don't have a lot of time. Pretty equipment, there's his equipment, objectives. Here's some of our treatments we looked at. And again, our check is, can we beat, what was that? That was a weird background. Can we beat no-till? Can we beat no-till 15s, which is surface applied, obviously? That's our check. With any of these other fertilizer placement, in-furrow fungicide, row spacing differences. That's what we're looking at, okay? Just so you know, with our placement, if we are strip till 30s and 30-inch rows, we put that strip right between the two corn rows. We centered it. If we were strip till 30s and still planting on 15s, we offset the corn row by basically 7.5 inches. Because if we didn't do that, what will we do? Plant a row right in that corn thing, we all know what happens there. Okay? So that's the configuration, if you will. We took a lot of Canopio data. There's some stand stuff. I want to get to the yield stuff because that's kind of the most important stuff. This is just that stuff. Okay, yield. By the way, if I didn't mention it yet, all of my information is on my website. My website is www.coolbean.info. Okay, this presentation is up there. And my Twitter is @BadgerBean. If you want to follow me on Twitter, I'm @BadgerBean. Okay? Anyway, so for those in academia, I'm going to come out right up front and say, yes, there was a significant three-way interaction. Okay? But to growers, they don't care. Okay? That's hard to sort out. So I'm going to walk you through the main effects and then dig into the interaction. So, main effect. Strip till out-yielded no-till by 7.2%. Banded out-yielded surface apply by 6.5. 15s out-yielded 30s by 6.5%. The pre-axor out-yielded non-treated control by 2.7. There's the main effects. Now, let's get into the interactions. Because the farmer is either going to have 30-inch row spacing or a 15-inch row spacing. And they're not going to flip-flop back and forth every year. So based on your equipment, these are our recommendations. In a 15-inch row spacing, okay, looking at the strip till here, we saw pre-axor out-yielded the non-treated control by 3.5 bushels per acre. The addition of adding pre-axor in furrow gave us 3.5 bushels. Okay? Pre-axor alone, this would be this treatment. Strip till out-yielded no-till by 4.7 bushels per acre. Okay? So basically we saw greater influence of the strip till over the no-till with that pre-axor. Next, farmers that are 30-inch row spacing. Okay, that's their equipment. The no-till, okay, which would be right here, these two. The pre-axor no-till out-yielded, they had treated check by 5.1 bushels. So the biggest bang for the buck that we saw with pre-axor in furrow was no-till 30s. Okay. Next, basically if we're looking at the non-treated control, which we compared this one to this one, strip till out-yielded no-till by 9.9 bushels. So basically what we're telling farmers, if you don't go no-till 30s, stick with your no-till 15s. If you are going to go with a 30-inch row unit, what do you need to do with it? Strip till it. And then we were able to capture 15% yield difference between the strip till versus no-till 30s. Okay? Lastly, pre-axor. Strip till out-yielded no-till by 5 bushels per acre. Okay? That, you all can figure out the economics that pays for itself. I gave up doing economics because I always get yelled at by somebody that my numbers are wrong. You all can figure out the numbers yourself based on fluids of application rate and price buying power and all that stuff. With that, I know I'm done. My website, Twitter, any questions, fire away. Otherwise, is there social tonight? No? Then I'll be up that way. Any questions? Awesome. Thank you for your time and have a good day.